Welcome to episode 9 of our series on cutting-edge technology trends. In today's episode, we're diving deep into the world of blockchain technology. We'll explore blockchain consensus mechanisms and delve into the complex realm of interoperability between blockchains. By the end of this episode, you'll have a solid understanding of these crucial components of blockchain technology. So, let's get started. Blockchain technology has revolutionized the way we think about data security, transparency, and decentralization. Initially popularized by cryptocurrencies like Bitcoin, blockchain's potential extends far beyond digital currencies. Today, it is being adopted across various industries, from finance to supply chain management, healthcare, and beyond. In this episode, we will explore two advanced concepts in blockchain technology: consensus mechanisms and interoperability. These are key to understanding how blockchains function and communicate with each other. Blockchain consensus mechanisms. Consensus mechanisms are the backbone of blockchain networks. They ensure that all participants in the network agree on the state of the blockchain. Without consensus, the decentralized nature of blockchain would fall apart. Here, we'll explore some of the most widely used consensus mechanisms. Proof of work, POW. Proof of work is the original consensus mechanism used by Bitcoin. In POW, miners compete to solve complex mathematical problems. The first to solve the problem gets to add the next block to the blockchain and is rewarded with cryptocurrency. Advantages. 1. High security. The computational power required to solve POW puzzles makes it extremely difficult for attackers to gain control of the network. 2. Proven effectiveness. Bitcoin's long history without major security breaches demonstrates POW's reliability. Disadvantages. 1. Energy intensive. POW requires significant computational power, leading to high energy consumption. 2. Scalability issues. As the network grows, the time and energy required for mining increase. Proof of stake, POS. Proof of stake was introduced as a more energy-efficient alternative to POW. In POS, validators are chosen to create new blocks based on the number of coins they hold and are willing to stake as collateral. Advantages. 1. Energy efficient. POS reduces the need for extensive computational power, lowering energy consumption. 2. Economic incentives. Validators are incentivized to act honestly, as they risk losing their staked coins if they try to attack the network. Disadvantages. 1. Wealth concentration. POS can lead to centralization, as those with more coins have a higher chance of being selected as validators. 2. Security concerns. POS is still relatively new, and its long-term security has yet to be fully proven. Delegated proof of stake, DPoS. Delegated proof of stake is a variation of POS where coin holders vote for a small number of delegates to validate transactions and create new blocks. This system aims to enhance efficiency and scalability. Advantages. 1. High throughput. DPoS can handle more transactions per second compared to POW and POS. 2. Reduced centralization. By allowing stakeholders to vote for delegates, DPoS can democratize the validation process. Disadvantages. 1. Potential for collusion. Delegates might collude to act against the network's best interests. 2. Voter apathy. If stakeholders don't participate in the voting process, the system can become less representative. Byzantine fault tolerance, BFT. Byzantine fault tolerance mechanisms, such as practical Byzantine fault tolerance, PBFT, ensure that a consensus can be reached even if some nodes act maliciously. PBFT requires a 2/3 majority agreement among nodes to add a new block. Advantages. 1. Fault tolerance. BFT mechanisms can handle malicious nodes, ensuring network security. 2. High efficiency. PBFT can achieve high transaction throughput and low latency. Disadvantages. 1. Scalability limits. BFT mechanisms can become inefficient as the number of nodes increases. 2. Complexity. Implementing BFT systems can be more complex compared to other consensus mechanisms. Hybrid consensus mechanisms. Many modern blockchains use hybrid consensus mechanisms that combine elements of POW, POS, and BFT to balance security, efficiency, and decentralization. Examples include Ethereum 2.0, which combines POS with shard chains for scalability. Advantages. 1. Enhanced security. Hybrid mechanisms leverage the strengths of different consensus types to improve overall security. 2. Flexibility. They can be tailored to meet specific network requirements. Disadvantages. 1. Complexity. Hybrid mechanisms can be more challenging to implement and maintain. 2. Potential for unforeseen issues. Combining different mechanisms might introduce new vulnerabilities. Interoperability between blockchains. Blockchain interoperability refers to the ability of different blockchain networks to communicate and interact with each other. This is crucial for the growth and scalability of blockchain technology, as it allows seamless transactions and data sharing across various platforms. The need for interoperability. As blockchain technology matures, numerous networks have emerged, each with its unique features and capabilities. However, these networks often operate in isolation, limiting their potential. Interoperability is essential for several reasons. 1. Enhanced functionality. Interoperability allows users to leverage the strengths of different blockchains, creating more versatile and powerful applications. 2. Reduced fragmentation. By enabling communication between networks, interoperability reduces the fragmentation of blockchain ecosystems. 3. Increased adoption. Seamless interactions between blockchains can drive broader adoption by making the technology more user-friendly and accessible. Approaches to achieving interoperability. Several approaches have been developed to achieve blockchain interoperability. Here, we'll discuss some of the most promising methods. Cross-chain bridges. Cross-chain bridges are protocols that enable the transfer of assets and information between different blockchain networks. These bridges often use smart contracts to facilitate interoperability. Example: Polkadot's interoperability solution allows multiple blockchains to connect and communicate through a shared security protocol. Polkadot's relay chain enables cross-chain transfers and data exchange. Advantages. 1. Direct asset transfers. Cross-chain bridges allow for the seamless transfer of assets between blockchains. 2. Flexibility. They can connect different types of blockchains, including public and private networks. Disadvantages. 1. Security risks. Bridges can introduce new vulnerabilities, as they rely on complex smart contracts. 2. Scalability challenges. As more blockchains connect to the bridge, maintaining efficiency can become challenging. Interoperability protocols. Interoperability protocols define standard communication methods for different blockchains. These protocols aim to create a universal language that blockchains can use to exchange information. Example: the Interledger Protocol, ILP, facilitates payments across various ledgers, including blockchains and traditional financial systems. ILP's connector nodes route transactions between different networks. Advantages. 1. Standardization. Interoperability protocols promote standardized communication, reducing complexity. 2. Broad applicability. They can be used across diverse blockchain networks and legacy systems. Disadvantages. 1. Implementation complexity. Adopting a universal protocol requires significant coordination and technical development. 2. Potential for fragmentation. Multiple competing protocols could lead to fragmentation rather than unification. Sidechains. Sidechains are separate blockchains that run in parallel to a main blockchain, allowing assets and data to be transferred between them. This approach enhances scalability and functionality while maintaining security. Example: the Liquid network is a sidechain of Bitcoin that enables faster and more private transactions. Liquid's two-way peg system allows Bitcoin to be transferred to and from the sidechain. Advantages. 1. Scalability. Sidechains can handle high transaction volumes without congesting the main blockchain. 2. Enhanced functionality. They can offer specialized features and use cases not supported by the main blockchain. Disadvantages. 1. Security risks. Sidechains can introduce new attack vectors, as they rely on different security mechanisms. 2. Complexity. Managing multiple blockchains and ensuring seamless transfers can be complex. The future of blockchain interoperability. The future of blockchain interoperability is promising, with ongoing research and development aimed at creating more robust and scalable solutions. Some emerging trends and technologies include: 1. Interoperable decentralized finance, DeFi. DeFi platforms are exploring interoperability to enable seamless asset transfers and lending across multiple blockchains. 2. Cross-chain decentralized applications, DApps. Developers are building DApps that can interact with multiple blockchains, enhancing functionality and user experience. 3. Interoperability as a service. Companies are offering interoperability solutions as a service, simplifying the integration process for businesses and developers. Conclusion. Blockchain technology is rapidly evolving, and understanding advanced concepts like consensus mechanisms and interoperability is crucial for anyone looking to harness its full potential. Consensus mechanisms ensure the security and integrity of blockchain networks, while interoperability enables seamless communication and asset transfers between different blockchains. As we move forward, the development of more efficient and secure consensus mechanisms and interoperability solutions will drive the widespread adoption of blockchain technology. This will unlock new opportunities and applications, transforming industries and shaping the future of digital interactions. Thank you for joining us for this in-depth exploration of blockchain technology. If you found this content valuable, please like, subscribe, and turn on notifications to stay updated with our latest episodes. Together, let's continue to explore the fascinating world of technology.